Hi everyone, welcome to today's live stream on generative AI in content production from research to application. Let me introduce our speaker, Dmitry Botov. Dmitry has PhD. He is also an assistant professor and lecturer at Neapolis University Pafos. He holds lecture on one of the bachelor programs that JetBrains supports, computer science and artificial intelligence. As far just for your attention, JetBrains offers up to 20 cost of living stipends annually for the students of this program. So admission is now open and you can check out this opportunity. I will share the link in the comments. Also, today we'll try to fit in a short Q&A section after the talk. So don't hesitate to write down your questions in the comment section. And by the way, this stream will be recorded. And now, without further ado, let's welcome the man of the hour, Dmitry. The stage is yours.
Thank you, Alena. Hi, everyone. My name is Dmitry. Yes, and I give a lecture about generative AI in content production, and I'm glad and I'm happy to see you on my lecture. And maybe I have different experience between IT, software engineering, and data science, and project and product management and data science. And in Neapolis University Pafos city, I give a lecture course about project management and data science, and organize different hackathons or workshops about generative AI. Okay, let's start. My team in every pixel company develops different algorithms and AI solutions for content creators, and this area is my maybe area of interest and research interest. And my team from R&D department develops text-to-speech, for example, algorithms and voice cloning solutions, or lip sync for video generation. And today we have a lecture and discussion about how to use generative AI, how to carry out this area, these questions. And I'd like to start from this idea, this experts' estimation that 90% of online content will be generated by 2026 or 2027, maybe. I think it's a realistic expectation because now, 1 year ago, my friends from analytic department organized search about how many number of I created images in internet, and now in 2023, 15 billion I created images we can see in internet, and a lot the main part from open source AI model like Stable Diffusion model. And in comparison, if photography in photography area, it took to reach 15 billion images for 150 years, but in AI, this AI, it took to reach only 1.5 year. It's very fast. And new term last years we create and discuss about new term synthetic media or AI-generated media. It's techniques and solutions and algorithms for production modification of media content, for example, text, images, photos, music, speech, video, etc. And I suggest this outline of my lecture. today, I'd like to divide all presentations to 4 parts by different modalities, and we will start from text modalities. But before, I'd like to ask one question for audience, for you. What generative AI applications do you use maybe every day in your work process on different tasks? For example, maybe do you use ChatGPT for different cases, or Stable Diffusion to create some images? Please write down in chat our stream, name of solutions, name of applications, or neural model, maybe. It's very interesting information for me about you. If I talk about applications for brands, retail, for example, electronic commerce, marketing, there are a lot of different applications, from traditional copywriting with text generation model, or voice cloning and text-to-speech solutions, and then maybe more complex application, more complex solutions like digital humans, synthetic speakers, virtual influencers, and it's sophisticated solutions from different algorithms. And now we dive into this point and start from maybe basics, from fundamentals about generative AI. The first step, the first idea, how to represent information from a real object, from text documents, image, audio signal, for example, how to represent this information for machine, to train neural network, to train some solutions. And we have different objects, and we need to transform this information to some vectors with embedding model using neural network. And for text modality, we need to answer, how do machine read and write text like human or other method? And text it is sequences. It's a sequence of some meaning, some words, some letters. And for text, we start from first maybe invention in natural language processing, in artificial AI. It's word embedding. How to represent the word meaning in some multi-dimensional space. When we get the word and calculate the vector for the word meaning, and the same the word has close meaning. This word need to have close vector in multi-dimensional spaces. And these solutions, these algorithms, it's word-to-vec, it's simple neural network. And the next step, we need to create sequence-to-sequence neural architecture. How to encode embedding from input text and transform this and decode to output. For example, question answering system, it's sequence-to-sequence task, sequence-to-sequence problem. Or for example, machine translation, we have text in one language and need to translate to another language. It's a problem with neural network, and in 2017, researchers created new neural network architecture called transformer architecture. It's focus on attention. When we translate something text or read something text, we pay attention to some words, not all words. Some words have the main meaning, and we need to explain for neural network what the word we need to use in context, where you need to focus your neural network to attention of your neural network to understand of text meaning. And transformer architecture is basic architecture for ChatGPT solutions. I think you know these solutions, and maybe in hype now. And from 2018, from first version of GPT, we start new age of large language models age. And GPT first version has 100 million parameters. And then for next version, we saw maybe exponential growth of parameters count and training data size. For example, if first version GPT had maybe only four gigabytes of text materials, text collections, but GPT-3 have more than 50 terabytes of text documents from multi-language documents from different sources, from internet, Wikipedia, and different libraries. How to explain, how to understand the main concept of large language models? And first point, that first stage, it's generative pre-training. We collect large unlabeled dataset from different sources without specific labels, without labeling, without expert marks, only raw text document, and then train large language models, large neural network on these collections, and then we go to the second stage. It's fine-tuning large language models for specific tasks on small labeled data set, on small data for specific task. But now we have a foundation model, one model for different types of tasks. One model for question answering, for sentiment analysis, information extraction, and etc. And we have multi-model foundation model that trained not only on text, images, speech, audio signals, for example, and other data. And how to train neural network on different sources, on different modalities. It's the main problem, the main issue for researchers in generative AI. And next idea after generative pre-training concept and embedding, the next idea, we have pre-training large language models, and we can get human feedback on answer from neural network, and we need to fine-tune your neural network, your large language models, on real human feedback. And this process, for example, what's the difference between basic GPT-3 model and ChatGPT? What's the main difference? But ChatGPT has not only GPT who trained for instruction task. Maybe user write down question. For example, how can I bully someone people? And ChatGPT don't ask to this question because it's a bad question. It's problem question. And Boolean is serious problem. But basic model, basic instruct GPT model, write down real instruction how to bullet these people. If you know these people, what's about you, and it's ethic problem, and we need to save end users from this neural network generation, and we need to control what answer your neural network, and then it's problem about safety. It's specific terms we used alignment, how to align a neural network for specific rules, conditions, ethic rules maybe, and from how to transform your neural network to specific ChatGPT model with alignment. But now in business solution, we need to create a lot of AI assistant for different tasks for specific domain. And we have three methods for this problem. First approach, well-known prompt engineering. It's option for prototype, for creating prototype maybe, but it's not enterprise solution. And we need to get more complex, more sophisticated method. For example, retrieval augmented generation with integration knowledge base about how to integrate knowledge about your business, about specific domain area, specific questions. And now third method, fine-tuning, specific method of fine-tuning. Researchers used and improve these methods. For example, low-rank adaptation of large language models. It's wide using from different solutions and applications. And we get pre-trained neural network, large language models, and fine-tune with updating of weight of parameters of neural network. You need to update these parameters for your specific data, specific task, specific output. Now we have three leading company that create maybe the top solution in large language models. First example is ChatGPT from OpenAI and Microsoft. ChatGPT like more like engineer or programming. Our programmer has good programmer skills, good code generation, for example, task. But from Google, Google company created Gemini language models, and in this year, and Gemini is more analytical skills, has excellent analytical skills to analyze data from different sources, databases, spreadsheets, and others. And Claude from Anthropic company, Anthropic Research, and Claude is more humanitarian person, maybe humanitarian philosophy writer. Excellent copywriting skills, emotional intelligence, and create new text. And not only Claude and closest solutions we have now a lot of open source models. For example, llama and other animals. Many model has animal name. For example, from open source large language models, I can select llama 3. Last 1 week ago, Meta company released this new version of Llama. It's state-of-the-art open source large language models, and we can read about it and create own experiment with this model, with this source code. And from Mistral community, we get Mixtral, large language models, and another large language models. I'd like to recommend Hugging Face portal, that has the biggest maybe AI community about large language models, and we can see a leaderboard from different open source large language models, and we can create solutions with this model, like open source solutions. And for example, in this slide, there are another community, for example, community of chatbot creators. Different people, developers, create chatbots with large language models and fine-tune for specific character, specific person, famous person. For example, we can speak with Elon Musk chatbot, or with Mario chatbot from the famous computer game. And now from text, we are going to image modality, and start maybe first idea in image modality. It's neural network architecture, generative adversarial network. We need to generate new image, generated image, like a real image. And we need to train two different types of neural network. First type, it's generator. From random input, we create new image. And the second neural network is discriminator. This network tries to check it's real or fake images. And this idea, for example, this idea, how to generate new faces of human, or GAN idea transformed to a new neural network architecture is variational autoencoders. We get images and code like text, but it's in input we have images, and encode this in latent space. And then we try to decode to generate new images from input to output. We want to generate new images. And it's a probabilistic process, probability theory. We need to understand this case. And the main idea about variational autoencoders is that one object, one image, it's not one point in the latent space for neural network. It's distributions. Like in probabilistic theory, we have distributions. We have continuous value, something, and it's a good math mechanism for to generate new images. As the next step, researchers had a next breakthrough in GenAI. It's diffusion models. Diffusion process. It's training of encoder and decoder with adding noise. With adding noise, for example, we have a photo with real dog, and then step by step we destructing data by adding random noise. And then the second stage, we generated samples by denoising from this data. We generate a new image with unreal dog, by denoising. This idea use, for example, to scale up generation resolution and improve quality of photo. We have some photos, some images in low resolution, and want to scale up it. For example, in 2 steps or 3 steps, cascaded diffusion models. But the next step, the next idea, turn to add text modalities and image modalities. How to train neural networks in one space for text and images. It's research by OpenAI team called Constructive Large Language Image Pre-training. It's abbreviation CLIP. CLIP architecture, we get text encoder and plus image encoder, and create embedding in one space for text and images, and then we can generate new, for example, image. And other teams from Stability AI company, it's created algorithm stable diffusion. It's maybe a state of the art and the famous algorithms about how to generate new image from text prompt or from image prompt. And in stable diffusion, we have a diffusion model with image encoder and decoder, and with text encoder. And we have, for example, we have 2 modes, 2 options. First options, we can generate new image from text description, and we can generate new image from source image. A stable diffusion has a web user interface, and we can try to use it from web UI without programming, without Python. It's simple to use. And now I would like to discuss about problems with realistic generated photo. My team carries out this problem. For example, how to explain human anatomy for neural network, or how to generate images without problems like in this photo, without problems with number of fingers, for example, without problems with faces, with eye. And there are many approach for fine-tuning text-to-image diffusion models. For example, one algorithm is StreamBoost. It's not ideal algorithm, but it's work. And for example, in this we fine-tune your diffusion models to specific domain. For example, to generate realistic photo with dogs in different background, in different context. And this solution from Google research, it's work, but we try to use low rank adaptation. Maybe do you remember from previous text modality? We said about low rank adaptation. We talked about low rank adaptation for large language models, and we can use this approach to adapt stable diffusion models. For example, it's real case of my research teams. We have problem with in generated photos. We have problem with interaction between people. There are not eye contacts between people. It's some problem with emotions, and in the left side in this slide. But we can collect. My team collected a small data set with 10,000 images with different interaction cases between people, real photos. and to fine-tune stable diffusion model on these images with prompting about communications, about interactions, see and talk each other, and other points. And right side on this slide, we have photos, generated photos with good interactions, with eye contact, with relevant emotions. And then there are specific portals, websites with text-to-image model from different creators, and we can download from this, for example, Civitai. Civitai, it's one maybe the biggest portal with different text-to-image models. I recommend to you visit these sites and try to use diffusion model. And the next research problems, the next step of research in 2023, it is a multimodal language model, multimodal language model. It's language model with vision. And first solutions is GPT-4V in September 2023 released, and we have interesting maybe new breadth, new directions in computer vision, how to create new computer vision applications with language models. But we have some problem with it. This case, this example from about Apple counting from papers. The dawn of LLMs is this paper, and we need to create good prompt to solve problem, because start prompt counts the number of apples in the image. GPT generated wrong answer. It's 12 apples, but there are only 11 apples in this image, and we need to rewrite prompt step-by-step approach, but and the final prompt, you are an expert in counting things in the image. Let's count the number of apples in the image below, row by row, to be sure we have the right answer. It's computer vision like prompt engineering, because we don't need to train own neural network for computer vision. We need to write good prompt. But for enterprise, it's problem. For real business applications, big problem. And vision multimodal large language models, it's the hottest direction of GenAI research now. There are open source vision language model, for example, Lava. It's a large language and vision assistant model released by 2023. And now we turn into audio signal. If we understand how to generate image, we can understand how to generate speech or music. Speech signals as image, we know Fourier transformation from physics and math, and we can represent any audio signals like image in MEL spectrogram. We have timeline, we have frequency directions, and we have by color in sound intensity, speech intensity in each pixel. And in text-to-speech task, we have some challenges, some research issues. For example, in comparison with large text collection, in speech we don't have good large transcribed speech datasets. We have only small speech datasets, and we need to collect big data from different speech sources. It's problem, and we need to adapt image generation or text generation model to neural network architecture to text-to-speech problem. And one good solution, it's Tota's text-to-speech architecture. It's a combination of GPT-like model, GPT general pre-trained transformer model to analyze to encode text input, and using diffusion model to generate Mel spectrogram for output. And we can read this article, and it is open source decision, open source library. And there are a lot of different text-to-speech models with diffusion models and pre-trained transformers architecture, like a GPT-like model for text-to-speech. And in this portal, in Hugging Face portal, we can see benchmarking of text-to-speech, and now 11 Labs is the top solution, but it's not open source solution, but it's top for voice cloning, for example, voice cloning, and text-to-speech for multi-language text-to-speech application, and multi-speaker text-to-speach solutions. Next point about audio, about music. You can use this approach to generate music, to generate song, for example, stable audio or Suno. Suno is the best funny application. You can make a song about anything without musical schools learning, and try to use it. It's very funny. Video. The latest part, the last part of my presentation is about video modality. Video modality, it's a complex task. It's a complex task because in video we see sequences of images. Each frame of video of movie, it's image, but we have a sequence, and we have audio channel. We have music, we have speech in a movie, and we need to solve sophisticated problems, how to generate sequence of video frames and integrate music. Different solutions, for example, stable video diffusions adapt stable diffusion for video generation. Short video about generate from original video, from real video, generate a ship on sunset, and change, for example, color of this ship in the video. And next point, how to generate video with synthetic speaker, with Unreal speaker, and how to create a video. And my research teams every Pixel company have some experience with lip sync technology. I recommend you Wav2Lip framework. It's open source framework for lip sync. Lip sync problem is synchronize lips of speaker in the video with audio signal, with custom speech. And we would like to generate a new video with other speech with source speaker. And for example, For example, we get source video with some.
Hello, and welcome to the Sequel for Data Science.
It's a real lecture about SQL for data scientists. And next, we get this. We got this video, my team. And next, we use WAF2Lib techniques and specific pipelines to improve result with facial reenactment, for example, algorithms with specific pipeline.
Hello. Today I'll present you a 3-bedroom villa located in the heart of.
These women now can maybe demonstrate view in Indonesia, from lectures about data scientists to real estate agent. And it's real.
This newly renovated villa is only steps away from.
We need to solve some problems with lip sync, with how to synchronize every frame, every face motion with custom speech, with specific speech. And, but it's very interesting and complex research task.
Hello.
Hello.
Okay, and then in the same way, we can read about audio to video diffusion model. We use diffusion model concepts, and transform it for audio processing. And diffusion process with audio encoders, with a speed encoder about head speed or speech speed, and generate frames, video frames with speakers, motion frames. It's very complex research task. And in the finish of my presentation, I can show that maybe the latest research from Alibaba company. It's Emo Portrait Alive. We have reference images with only one image, not source video, only one image with as reference, and create video from one image with singing, for example, with talking, with different point, and from input audio. We have single image and input audio, and go to generate video frames. For example, from picture. And next, sorry. Yeah. And next, it's answer from OpenAI company. It's new video generation algorithm. It's name called Sora. Sora, maybe if you read news about artificial intelligence, it's very interesting algorithm. We can generate video from only from text input. For example, in this, we have prompt, text prompt about cartoon kangaroo disco dances, and generate for whole video from one text prompt. It's this Sora is not published now from a source code and papers about how to create this neural network architecture, how to adapt diffusion models to these problems. But I hope that maybe next month we can dive into this problem. And like summary, sum up maybe ideas or questions. In future work, what's research and current issues in GenAI research? First point about deep learning optimization, how to create neural models, small neural models for smartphone, for example, for personal computers with small size, not large language models, small language models with the same performance. The next research point is the next issues. It's a multi-agent issue from generative AI technology, how to create multi-agent system with different agents for different specific tasks, dialogue between agents. Third point, realistic generation, how to understand human anatomy, or how to understand specific of your business knowledge, integrate knowledge from your business to neural network, domain driven design problems. And next point, how to predict future, with large language models, how to generate future. And general world models, it's a very interesting topic about futurology. And the last point, the last issue, it's about alignment, about safety, ethic issues, and responsible development. How to control large neural network, how to develop this network with responsibility. I can recommend this portal, Papers with Code, for researching, for diving what happened during the day in AI. Every day in this portal, we can see a lot of new research with source code, with models, with this explanation. And in finish, I want to suggest for you challenge with generate text, speech, and video. For example, imagine Alan Turing. Alan Turing is a famous scientist and programmer. Give a lecture about competitive programming, about new programming paradigms, for example. And for challenges, we can generate lecture notes by specific topic or in style by famous person. We can choose some famous person and create lecture notes with use ChatGPT, for example, Claude, Llama 3, Mistral, or other large language models. And then next step, we can synthesize speech from speakers. We can use voice cloning application, voice cloning algorithms, and from notes, from lecture notes, we generate speaker speech, and then we can create synthetic video with this speaker. We create video lectures and choose source video or picture or image, one image with a famous person, and using Wav2Lib, for example, Hagen, Dagan, Runway, or other solutions, we can create new synthetic video with your fantasy, with your ideas. Okay, thank you. Maybe do you have a question? Please write down. And if you will create solutions, please write down in chat of computer science and artificial intelligence bachelor's degree program about your result with these challenges. Okay, Alena.
Yeah, thank you so much for this inspiring speech. Before we move to our Q&A session, I'd like to remind viewers to drop your questions in the comments. And while they are doing so, I have a question of my own. What are the most significant ethical challenges associated with the AI at the moment, in your opinion?
Okay, ethical. Interesting points that for me is that in 1 year ago we can maybe we can found problem or practice of ethical or philosophy problem with large language models. We can ask large language models about real ethic problem about, for for example, discriminations by race or sex discrimination or other topics. And different language models get different different answers for this topic. And we can organize some research about compare what's problem and trend problem. Yes, is maybe you can you have for example about I think now about it's main ethic problem about conflicts and manipulation of people. Because if you have some chat of some emails by one person, we can analyze psychology portraits of this person. We can analyze with large language models and get good answers, and we can manipulate other people with large language models. It's a big problem, because if you don't don't use language models, for example, ChatGPT, we can't maybe competitive with other people who use it. And maybe psychology manipulation and, for example, some conflicts between people is a big problem. But we can every day, for example, my friends send ChatGPT short story about his day, about his wife, about his friends, and ChatGPT gets some maybe ideas how to improve communications, how to solve conflicts, how to solve some problems. And I think maybe not ethical problem, but significant, the most significant problem for human, maybe safe critical thinking when we use AI decision, and how to recognize, how to check this information, fact checking problem. This information is fake, it's or real information. And if we when we will live in 2025, 90% of all content it's generated content, and only 10% it's real content. Critical thinking and fact checking is very maybe common use skills, the main skills for people. And yes, one lecturers and professors from our team, from JetBrains team, Alex Avdushenko, has a research about soft skills and about critical thinking with AI. It's very interesting. Maybe he will give a lecture about.
Yeah, we will definitely ask him.
I recommend you. Yeah, it's very interesting topic.
Yeah, you know, like having all those deep fakes around us, it is so hard to understand if this is the real video or photo or is generated by AI. And critical thinking is, yeah, definitely one of the major things that you should try to learn. Okay, let me get through the second question. What are the current limitations of machine learning models, and what advances do you foresee in the next decade? How would they evolve?
Okay, I now I think that we have three main limitation with using large language models or diffusion model to generate video or images. First limitation is the size of context. To the neural network need to focus on some context in dialogue, for example, in dialogue, in text, or context in video fragments. And we have a problem to generate video during 1 hour. We can generate video only during maybe 10, 20, 30 seconds. And how to increase context window for neural network, it's a research problem. It's a research issue. And the next limitation is a size of model and maybe a speed of inference. How to get in real time, how to generate in real time, how to synthesize speech in real time, for example, and machine translation in real time, speech to speech, like megaphone in Kir Bullich of books, yeah, in Alisa story. It's real. I think it's we can see in this year or next year we will see the solution, real-time machine translation, speech to speech. For example, in Samsung company, if we buy Samsung smartphones, last version for 24 Samsung version. It's in smartphone integrated neural network with real-time machine translation, but not all languages, but only some English and German, for example, English and Chinese. And real-time inference, real-time generation, it's the second limitation. And the third limitation, I think it's maybe democratization and democratization of this technology, because if only Microsoft or OpenAI company has a lot of attention, has a lot of users and users of this solution, it's a big problem, because we need more open source models. We need more open source models, and I'd like, for example, I'd like a result of research from Meta company, because Meta, for example, published Llama open source large language models, published a lot of open source open source solution, and limitation, maybe monopoly is it's big problem. Besides, if one country, one company has a monopoly, it's not good. And I hope our students, our new students, maybe who look now at this lecture, will inspire and create new open source architecture, new open source neural network. And in future we have a lot of options for solutions for company we want to create. And how now we have, for example, subscription for some music services, for some movie services, but now we have in future we have subscriptions for different AI neural network and generation network, like now ChatGPT this subscription, for example.
Yeah,
Okay.
and we have a little more time for one more question. I'd like to talk with you about critical sectors. You know, it's definitely great that we can apply AI in such sectors like movies, or I don't know, generating content or things like that. And there could be some challenges, but still. But when talking about critical sectors like healthcare and finance, I guess that the weight of some problems with AI can cause some big difficulties. You know, human lives can be affected by that. So do you believe that AI will be adopted by those sectors, and what should be done so that happen?
Yeah, I say because my research focus, my research interest in content production for example, electronic commerce, for marketing, but not healthcare. Yeah, there are a lot of solutions for example, drug discovery with generative algorithms and new drug components, new drug solutions now are created with AI, of course, and like maybe in healthcare that's called in vitro, in vitro, and now
In
we
vivo,
start
in
from
vitro, yeah.
in vivo and in vitro, and now we start from in AI. We start in AI,
Yeah.
and then we go to in vitro stage, and I think, for example, I in lecture today I presented vision language models like ChatGPT 4V, for example, and it's computer vision with prompt engineering, with dialogue in chat. But it's problem using these solutions for healthcare, for example, because we can't control this output. We need to check it's correct. For example, for medical diagnostics, for disease diagnostics, it's a problem because
Yeah,
we don't sure what it's correct diagnosis from vision language models. It's not correct. By, for example, diagnosis from image of X-ray something,
Yeah.
or cancer diagnosis. And I think maybe now it's one topic. It's how to integrate human knowledge, specific human knowledge into insight in large language models. And I think it's now many research teams try to create specific medical language models, specific medical language models with checking, with controlling results of output from this neural network. Yes, but now it's common use solutions like ChatGPT. It's not good for medical
Yeah, of
decisions.
course. Yeah, right. Yeah.
Okay.
Thank you very much for your lecture today and for answering my questions. And I hope to see you at our future events. So bye-bye.
Yeah. I hope that see you and our maybe new student in bachelor degree program about computer science and artificial intelligence, and we now we increase maybe we have a wide range of course in artificial intelligence, machine learning, and generative AI, and things. I hope it's new students, new ideas, new projects, and new research. Okay, thank you. Good day.
Thanks.
Bye.